So we're going to watch the trailer now for anybody who hasn't seen it, and then we will get into our Q&A with Becca Solstad Siegfried.
This is Delta Launch Control.
Go for launch.
3, 2, 1, engine start, and liftoff.
Yeah, it's only a robot, but she becomes a family member.
Our whole objective was to build 2 solar-powered rovers that could survive 3 months on Mars.
And the pressure on the team is really phenomenal. Was Mars once a green world with living things and blue oceans?
This is the very first time we breathe life into the rover.
It's just a box of wires, right? But you end up with this cutish-looking robot that has a face.
Oh, it's alive!
It's time to fly.
Ladies and gentlemen, you are privileged to be in one of the most exciting rooms on Earth at the moment.
Rover diary. The signal from the vehicle is solid and strong. Opportunity is on Mars.
What do we do next?
Let's hit the road, pedal to the metal, and go see Mars. We see these dust devils, and we were concerned that would be the way that she died.
Mars was a spacecraft graveyard when we flew.
I don't think anyone expected the rover to survive all these disasters. You get this feeling of we're basically invincible. Through this robot, we are on this incredible adventure together.
Humans are capable of forming a connection and a bond to a robot.
She rewrote the history books.
Good night, Opportunity. Well done.
Amazing. Well, thank you so much for joining us. This was such a cool way to learn about your work and your mission. So for everybody at home, you may, if you watched the film, you already know Becca's face because we saw it over and over again in the movie. So you originally got involved because you were in the room when they launched these 2 rovers, and then you ended up working at JPL since 2013, right?
That's right. Yep.
Amazing.
And I was actually in 8th grade in my classroom watching the rovers land. So I wasn't actually in the room, but it was an incredible experience nonetheless. And then, yes, I started working at NASA at the Jet Propulsion Lab in 2013.
Amazing. So also I love your scarf. It's very on theme for today. Amazing. Okay. So we have a lot of questions, so I'm just gonna get into it. So first question is from Maria. How were you able to accomplish the Opportunity mission with old technology? Will you redo the mission ever with newer technology? This is from a BIS student in Barnstable, Massachusetts.
Yeah, excellent question. So it was kind of funny coming from college where, I was doing my homework on a Mac computer and submitting my homework through the internet, and then coming to the Jet Propulsion Lab where I started working on Spirit and Opportunity, and the technology was really old. And I was communicating with the rovers using technology that I think probably my parents used, or maybe somewhere in between myself and my parents. But you learn, and it's actually it was a really easy way to communicate with the rovers, the technology that we were using. It was really straightforward. Some of the things we had to do were pretty manual, unlike where it could be done by a computer. That's what we call autonomous. A lot of things were more manual, but it allowed us to really learn, and doing those manual steps allowed us to really get to know the rovers really well. Now that I work on Perseverance, with every rover, we keep increasing the technology. So with Perseverance, we are doing some crazy awesome things with very brand spanking new technology. And we are able, once the data hits the ground from the rovers, they send it from Mars and it gets to Earth, we can actually process that data super quick, and that data turns into what we call information, data to information, in a very short period of time, which is unlike anything we've been able to do. I would say on the order of like 5 to 10 minutes.
Very cool. We've got another question. Would the water on Mars be drinkable if we could melt the ice at the poles?
Yeah, that's also a really good question. It depends on a lot of things, but we do think that we have found the evidence of drinkable water on Mars. Now, the ice at the poles, we're not quite sure, or I should say, I'm not quite sure if that was the more acidic water, which we know also exists on Mars, or if that water is drinkable, that ice. But you could imagine if you had the right science instruments, you could melt that ice down and split apart and take out just the hydrogen and oxygen molecules that you need to make water. So maybe some of you out there know that water is made of H2O. So you could boil that down and just pull out 2 hydrogens and 1 oxygen molecule to make pure drinkable water. So that's something that we're looking into too for a future technology.
Very cool. So one thing that really surprised me watching, so I'm, as you may or may not know, I'm a squid biologist. I work in the ocean. I don't know almost anything about like robots or Mars. So watching this movie, I learned how slow these rovers move. How fast are they going at any given time? And why don't they go any faster?
Yeah, so that is also a very good question. The rovers move slower than you might think. That has to do with a couple of things, but the motors that we have turning the wheels, that's about as fast as they can go. So every single thing that we send to Mars, we have to know that it's going to be safe on another planet. And so we can't just send whatever we want from the auto shop or anything. We have to test the mechanisms a bunch of times. And sometimes we even send them into space to make sure they work in space, because the environment on Mars is very different from Earth. We don't have an atmosphere to protect us like we do. So the motors that we happen to use were super, super tested, and they just happened to also be pretty slow, but we didn't need to go any faster. Now on Perseverance, the newest rover, we can go a bit faster than that. But yeah, it just depends on whatever mechanisms and technology that we have that we can use that's been super, super tested, so we know it can survive in a space environment.
Very cool. Sounds good. So you as a group worked with these rovers so much longer than you expected to, and really got like emotionally connected. You could obviously see that from the film, like people getting really emotional about it. So as a group, like how did you grieve the rovers when they stopped working?
Yeah, I remember that day like it was yesterday. You can imagine it's very similar to a funeral. Now we more called it a celebration of their life, Spirit and Opportunity's life, and we celebrated all of the incredible science that they were able to send us over the course of their lifetime, and the fact that they did survive so much longer than what we built them. It was at least a happy celebration of their life, but we were all in a room together. So there was a couple of phases. It was when NASA announced for the last time that we were going to try one last time to communicate them, that was one opportunity that we were all together, and a lot of us were crying and grieving. And then I think the most emotional part was when Steve played the last wake up song, Steve Squires, and we were all there together. So that was like a few hours after we had that first briefing with NASA. So that was the most emotional. And then we had another chance to all get together after we had called the mission off, where a lot of people from JPL, not even just the people who worked on Spirit and Opportunity, but like the entire lab had a chance to all get together and grieve. So there were some chances to get through that together, and it was really important that happened.
Yeah, for sure. Thank you. The next question is from Wiley. Has Perseverance ever cited Spirit or Oppy? And then we have a question from Caitlin's Rose Gaffney's 5th grade class. Did Oppy ever meet Curiosity, launched in 2012?
Yeah. Okay. So the answer to that, both of those questions, is no, but I have some good news for you. So, okay, first of all, if you imagine a planet, right? So like Earth, Mars is smaller than Earth, but still, if you can imagine Earth, think about putting 4 different cars on Earth at like spaced at different parts. So Mars is pretty big compared to the size of the rovers, and they're all that we purposely placed the rovers in different parts of Mars because we wanted to explore different parts of Mars. And we had a lot of questions, and we wanted to get the diversity of different parts of Mars to really understand if life could have existed there. So none of the rovers right now are close enough together, even Spirit and Opportunity, who are twins, none of them are close enough together to meet each other. However, we are building Mars Sample Return, which is the next rover after Perseverance, and Perseverance and Mars Sample Return, the lander that's going to be there, are going to meet each other. That's at least the plan right now, because Perseverance is going to hand over samples to the lander, and the lander is going to take them from Perseverance and put it in her belly to like launch a little rocket off of the lander. So that's going to be so exciting. It'll be the first time where 2 missions actually meet like that on Mars. So keep your eye out for that.
Cool. That's going to be really exciting. A question from Tristan: is Curiosity living longer than we'd expected to?
Yes. Curiosity, we thought when we built the next version, the next generation of rovers with Curiosity, we built them to last. So we never said 90 days. What we said, though, for the primary mission of Curiosity is 2 Earth years, or really 1 Mars year. 1 Mars year is about 2 Earth years. So that's what we said. We can at least guarantee that Curiosity will last 2 Earth years. Well, Curiosity's been on the planet for 10 years now. So she's well past her life expectancy also, and will continue. She's looking really good. So Perseverance, we knew she could probably last about as long as Curiosity. And so Perseverance is trying to last now until we get Mars Sample Return on the planet, which is in about 8 years. So we didn't necessarily design Perseverance completely to last 8 years, but with all the data that we have, we are very confident that she should last another 8 years.
Cool. Sounds good. All right. We got a question from Kay. What kind of math was used for Operation Opportunity, and what kind of math do you use like every day at work?
Yeah. Okay, good. I'm glad y'all are asking about that, because in high school, I really saw for the first time how what I was learning in the classroom could actually help me in life, and especially with my job in engineering. So the math that we use a lot is algebra. Everything's pretty much algebra based. There is some calculus that we do, but everything kind of builds on each other. So algebra, I would say, if you can, get help in really understanding algebra, that is the building blocks for everything else you'll learn. Trigonometry we use a lot too, but it all stems from really understanding algebra. I had a really tough time in high school with math, actually. And I ended up not until college, and I wish I would have done it sooner, but in college, I got a tutor to really sit down with me one-on-one and help me with math, because I knew it was the building blocks for the rest of my career and what I was going to be learning in school, because I really wanted to be an aerospace engineer. And getting that tutor was really, really helpful. And once I really understood algebra, everything else came a lot faster. I actually got really good at math, just knowing algebra pretty well. So hope that answers your question.
Awesome. Thanks. Our next question is from Maeve from Boston. How did you come up with the names of the rovers?
Okay, good. So there is a naming competition that happens with every single rover. So keep your eyes out, because we'll have the same naming competition with Mars Sample Return. We call Mars Sample Return that now, but she'll eventually get a name as well. So middle school, high school, I think even elementary school kids have a chance to name the rovers, and you write an essay for what you want to name it. And we, like the mission operations team, get to read through all the essays. We split them up amongst us all. We get to sit down and read a bunch, and we vote on the name based on the essays that we receive. So there will be a naming competition for the next rover. Please submit your name for whatever you think the next rover should be. And hopefully you'll get the name. You'll get picked to be the name. And then you get a day, come to JPL. We bring you to JPL, and you get to sit in with the mission operations team and spend a day in mission operations and get to operate the rovers with us. So it's a really cool thing.
That's awesome. It sounds like fun. Our question next up is, why was only one rover sent with Perseverance and not a team of 2 like with the previous mission?
Okay, good. So Spirit and Opportunity, the reason we sent twins was because of a word we call redundancy. So redundancy is when we decided to send 2 of them, hoping just one would survive. So it's kind of like getting in baseball when you get 3 strikes, you get 3 chances before you're called out. It's kind of like that thing that we wanted to try twice before. So the reason at Curiosity and Perseverance we didn't send 2 is because instead on each of the rovers, first of all, we proved that we know how to land on Mars now. So we used that understanding and decided to just build 1. But on Curiosity and Perseverance, they each now have 2 computers. So so you can imagine like, your desktop at home or a laptop that you have. Imagine we just decided to stick 2 of them on there. So if one computer dies, we have a backup. So we still have redundancy. It's just on 1 vehicle instead of 2.
Cool. Okay. That makes sense. Our next question, what has been your favorite moment working on Oppy?
Oh my gosh, on Oppy. There are a lot. So in the film, if you remember, we talked about how Oppy was losing her memory, which was right around the time my grandmother was. And I think, so number 1, I got to lead the effort on trying to figure out how to restore Oppy's memory. They kind of named me. They didn't know my grandmother was also going through the same thing at the same time, but it was a really special problem for me to solve because I couldn't solve it for my own grandmother.
Yeah.
But I had to solve it for Oppy. So I was in the test bed a lot, the Earth-like version of Spirit and Opportunity, testing out all these different ways we can try and revive her memory. And I figured out a solution. I ran it by my whole team. We tested. Anyway, we ended up sending the solution up to Mars. And for me, it was the moment of receiving the data back from Oppy saying, I did it. I have my memory back. And then I got to report it up to Steve Squires and the whole science team. And I remember he gave me a high five, and it was just a very emotional thing for me, I think personally, because of the connection with my grandmother. So
for sure. Yeah. Super emotional. Okay. Speaking of emotional things, the choosing of the wake up song was like also a very cute thing. Who picks the wake up song? Is it different every single day? Like, what is that? That's like such a fun aspect of this whole program.
Yeah, for sure. So the flight director gets to pick the wake up song. So you can imagine, okay, so in operations, we really have 2 different teams, and one team hands off to another team. So you can imagine like doctors handing off patients when they've worked their 8-hour shift. So we have the downlink team and the uplink team. And the downlink team is responsible for getting all the data on the ground, analyzing it, processing it, and figuring out what we can and can't do that day based on the information that we have. So in that room, the downlink room, we have a flight director and a bunch of other subsystems that are analyzing the data and report up to the flight director. So the flight director kind of kicks off the day once we get when we're about to get the data down or when we just got the data down. And that's the role that I had. I was a flight director on Opportunity. And it's that role that gets to pick the wake up song. Usually it's a theme. So like if we're doing something special that day, we'll try and find a song that kind of like goes with the theme. So for example, on Perseverance, I was also a flight director. The title then was the Tactical Down. I was on shift the day that we decided to deploy the helicopter. We brought a helicopter with us on Perseverance. And the helicopter was mounted on the bottom of the rover with these bolts. And the way to release the bolts to drop the helicopter was with pyro. So like a firework. And we have these little fireworks on the rover mounted, and you like shoot the fireworks off, and it's not really fireworks. It's like a little release. But anyway, you can kind of picture it like that. And it drops the helicopter. So anyway, that day I decided to pick the song Canned Heat. I got canteen in my heels tonight, baby. That song. And I explained, like, this is what we're doing today. This is the data we're about to see. And then I played that song. So there's usually a theme with the song that we pick. Or if we're going through a really stressful time, it's something like ABBA or, something that, or the Beatles, something that goes with the theme.
Yeah. It's also seemed to be music from like before 1995. I was like,
that's the best kind of music.
That's just the vibe of the room.
It's vibe, yeah. And they pick more current songs too, but yeah, it's usually like older songs because the lyrics are just so good.
That's fair. That's reasonable. All right. We got a question from Samantha T from Hyannis, Massachusetts. What kind of cameras were on the Opportunity rover?
Yeah, we had really old cameras on Spirit and Opportunity, but they were great. They worked really well for what we needed to. And it kind of goes back to the comment I was making about making sure the things we send into space will last.
Yeah.
So we picked cameras that we knew would last. But I don't know if you could tell in the movie. Yeah, we did show, like, so when we did the selfie, all of our cameras on Spirit and Opportunity are black and white images. And we have a calibration target on the rover, which we knew all the colors on this little palette on Earth before we sent it. And then we would take a picture of it with all the colors. So we knew what colors things were based on the camera taking a picture of the color palette. Does that make any sense? Yeah. It's a really cool way to think about it. So we are actually able to add color to the images on Earth when they come down from Spirit and Opportunity based on this like color palette calibration target that we had on the rover. So if you see any color in pictures from Spirit and Opportunity, those were added on Earth, not from actually the cameras.
Very cool. So in the film, you see like one of the rovers coming up, and I think having their little like camera arm grabber, or not grabber, but camera doodad. And it like goes up to a rock and is like, this one's volcanic rock. Does that mean there's more than a camera on there? And what is the device and what are we sensing and measuring?
Yes. Okay. So on the arm, the turret is what we call it. There, I think were 4 instruments on the turret, and it can turn and like you get a new instrument, and then it'll turn again and you get a new instrument. So we had one of the things was called the rock abrasion tool, or the RAT. And it would grind down on a rock, which kind of, if you can imagine, like, you're out in a field and you see a rock and like it looks one way, but until you scratch the surface, you can't see really what it looks like underneath, which is the thing that hasn't been exposed to the environment for a while. So that's what the RAT does, and we use that a lot. But the thing you're talking about was the microscopic imager, the MI. Okay. And then we have a little camera where we can like zoom in and look up like a microscope, look really, 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 really close up on rocks. And so that was another tool. And we have other various tools on the arm. And then we have other instruments all over the rover to do different things.
Cool. Very cool. Holly from Boston wants to know, were there rovers that came before Spirit and Oppy that didn't work?
No. We had one rover before Spirit and Opportunity, which was Sojourner. And Sojourner was launched with Pathfinder. So Sojourner was about the size of a microwave oven. Very, very small. And if you ever watched The Martian, if you go see that movie, Sojourner, it's not actually Sojourner, but a model of Sojourner is in the movie. And it's like the little rover that kind of runs around with Matt Damon in the tent. That's Sojourner. So you can imagine that. But she worked really well. In fact, she was the technology demonstration to see if we could have a rover on Mars. So Spirit and Opportunity are based on our understanding of Sojourner. Curiosity is based on our understanding of Spirit and Opportunity. Perseverance is based on our understanding of Curiosity. So like Perseverance is the great granddaughter of Sojourner. And we learn so much every time we launch a rover but yeah, all of the rovers we've sent to Mars, at least the United States has sent to Mars, have worked.
Sweet. That's great. Molly wants to know, why is a day on Mars called a sol?
Good. Okay, so we can't call it a day because the definition of a day, if you look up the definition of a day, it's 24 hours, which is however many seconds you calculate that. 24 times 60 times 60. That is the definition of a day. A sol is 24 hours and about 40 minutes. So one Mars day is a little bit longer than an Earth day. It didn't have to be that way, but that's just happens to be the amount of time that the planet makes one revolution. It's about 24 hours and 40 minutes.
Okay.
And so we had to name it something other than a day.
Right.
So a sol is based on the sun, and it's like how many times anyway, I don't actually know why we called it a sol per se, but we needed another name for it. And I should actually look that up. That's a really good question.
Sol is sun and something. It's the word for sun in like Latin, maybe?
Yeah, I think Spanish it's also called sol.
I think so too.
Yeah.
German. And that's not helpful in this situation. Yeah. Cool. Oh, so on every different planet, do we need a different word for day then?
Yeah.
Do you happen to know any of the others?
I don't actually. I've only ever worked on Mars. I should though. That's
a
thank
good
you for
trivia
asking
question.
questions. Yeah, we should all go look that up after this.
Should look that up.
It's possible though, if we haven't landed anything on another planet, we would call it like a Venus day or a Mercury day.
Right.
Just a day because that's an Earth day until we came up with the name. But it's possible Venus and Mercury also have names for a day. Now, if you think about it, the gas giants we can't land on, and so maybe calling them a Jupiter day doesn't make sense because you can't ever, it's like not a solid body that a day would ever matter. Anyway, now I'm starting, I don't know. I'll look that up after this.
Sounds good. Gas planets, are they denser in the middle than on the outside?
It depends.
Okay.
It depends. So Jupiter is less dense than water. So the whole planet is super, super less dense than water. Meaning if we had a bathtub big enough, it would float, which is just like a crazy thing to think about. But so are they denser in the middle? Probably they are. But I
have no idea.
You have to ask like a planetary scientist about that. They would know. But I
just wonder, like, is the approach to studying one of those planets, instead of sending a little rover that rolls around, like imagine that you're sending an ROV like we do in the ocean, where you're sending something to go swimming in gas instead of floating on rock.
And they've done that, and they're actually thinking about doing that on Europa. Oh, you would love.
I talked about that before you got here. That's what I rambled about. So my buddy Pete works at Harvard, and he is working on like the things that we will send into that liquid. Yeah.
Oh my
gosh. So cool. So cool.
Europa is the coolest moon in our solar system. I think it's going to be really cool. But on Titan, we sent Huygens probe, which was like a little thing that we sent down into a really I'm trying to think the gas right now. I'm drawing a blank on the gas that we have on Titan. Wow.
I have no idea. Yeah.
I'll think of it in a little bit. But anyway, we sent a probe to measure a bunch of stuff. So we called it a probe. It didn't land, but like went through the atmosphere and methane. It was methane.
Mm-hmm.
In fact, methane is liquefied on Titan. So it like went through the methane lakes. I mean, it's crazy. Wow. It's a cool moon too. But Europa, I think.
Cool. So we kind of, one of the questions was, are there plans to send rovers to other planets besides Mars? We just covered that. Wonderful. And we're kind of coming up on our time here. So I want to make sure, first of all, thank you so much for taking the time to spend with us. This was really, really interesting. Is there anything that you like wish everybody knew about either working on rovers, working with NASA, anything about your area of research that you just wish everybody knew?
Yes, that's a great question. So I grew up, and I think I mentioned this in the film, but I grew up in a very small town in Texas called Fredericksburg. And I had no idea. I didn't even know what an engineer was. And I thought it was like someone who drove a train for the longest time. But what I'm trying to tell you guys is I came from a small town where science and engineering wasn't like the biggest thing ever. But I always thought space was so cool. And I happened to build rockets in high school. And so my message to you all is if space is interesting or anything else out there that interests you, whether that's ballet or cooking and becoming a chef or whatever it is, if you have the if you have the passion, you can do anything you want to do. I had to work really hard to do what I do. Like I said, I got a tutor to help me with math. So there are people out there that can help you. Ask a lot of questions, listen to your elders. Like we also listen to Spirit and Opportunity. They were our elders and they helped us learn things too. But yes, get help if you need it, and you can do anything you set your mind to. You really, really can. So I hope that will inspire you to shoot for the stars. And I wish everybody here good luck in life. And if you also want to work on in space, there's a lot of really exciting stuff coming up, like Mars sample return. We're about to get samples back from Mars for the first time, and things are just going to get more exciting in the space industry. So, I'm biased, but if you want to go that route, there will be a lot of fun things ahead of you.
Awesome. This has been very, very cool. Thank you for taking the time and sharing your knowledge with us. This was awesome. Everybody at home, if you still have more questions, if you want to talk more about space, starting in early January, we're going to be opening up matches between scientists and classroom, scout troops, libraries, anybody who needs to talk to a scientist. So you can always sign up there. We've got space scientists ready to go. They may not work at NASA, but they're still space scientists. So you can talk to those. If you haven't seen Goodnight Oppy yet, you still can. I just posted a link in the chat. Just use the code Friday PM anytime between now and 6 p.m. Eastern tonight. And then you can watch it anytime after 7 p.m. tonight. Thank you to Becca for being here and sharing knowledge. Thanks to the team at Amazon who brought us all together, and to Lindsay Phillips, who's been sending us all emails and coordinating all of us to get together and make this event happen today. So thank you all. If you know anybody that you wish would have seen this, it will be on YouTube at youtube.com/Skype-a-Scientist in about an hour. So thanks again.
Thank you for having me.
Of course. Goodbye.
Bye.